So today we are going to begin a new chapter, and it is chapter 10, Properties of Gases. Okay, in this chapter we're going to have a look at what is a gas, our gas laws. We have Boyle's law, Charles's law, and the combined gas laws, along with the equation of state for an ideal gas. We're going to look at what is an ideal gas, what is a real gas, and finally then we're going to look at an experiment. So firstly, just to introduce, we're looking here at a gas. So we know that from our junior cert that we have three states of matter. We have solids. Solids, all their particles are very tightly packed together. They have a definite shape and a definite volume. We have liquids. Particles are a little bit further apart, so because of that they're able to move, so liquids can flow. They have a definite volume. I can measure out 250 mils of water, for example, if I'm baking a cake. But they have no definite shape. They take the shape of the container in which they're placed. So an example there would be a basin versus a bottle or a jug. Okay, so depending on what is actually placed in it. A gas then, and again from our junior cert, we know that they diffuse. Okay, so they have no definite shape. So we say that they have no well-defined boundary because they have no definite shape, and what they do is they diffuse rapidly to fill the container in which it's placed. That's why if I spray perfume, I eventually can get that smell at the back of the room if I was to spray it at the top of the room. Why? Because the particles in the perfume contains gas particles, and those gas particles diffuse. Remember, particles in a gas want to move as far away from each other as possible. We've already briefly looked at this when we started our course. And if you remember, I showed you a demonstration of online of this. So on one side I have ammonia, NH3, and on the second side I have cotton wool with HCl. And when I looked at this, I looked at it that we have particles that are extremely small. And what I ended up forming was about 3/4 away across the test tubes here, I had a white cloud being formed of ammonium chloride. Okay, again, this is gas particles, so the HCl here produces particles which are gaseous. Likewise the ammonia, and again they move. The ammonia particles here, 14 by 1 by 3, gives it its relative molecular mass of 17. And chlorine and hydrogen is 36.5. So if I look at this, my ammonia particles are moving more rapidly. Why? Because they have less of a mass. And the reason why I know they move more rapidly is because this white cloud is further over towards the HCl side. Okay, so that is a small little demonstration of gas particles moving by diffusion. Remember, gas particles always fill out the area in which they're placed. They want to move as far away from each other as possible, and that is called diffusion. Okay.